Hello everyone, just thought I'd explain this quite complicated heat pump system that I've been tasked with improving the efficiency on. So heating this property, we have two Vaillant 12 kilowatt aroTHERM plus heat pumps, providing underfloor heating throughout, plus a towel rail circuit, and providing hot water for the entire property. So the first thing I did here was I checked the commission settings and the heat curves. I could see that the efficiency, we were only getting a cop of 3 when normally we get a cop of 4 on these systems, but thankfully I didn't install it, didn't design the system, but we are here to improve it. So what I noticed was the heat curve was on 1, which is really high for underfloor heating throughout, and I can only presume it was that high because of this towel rail circuit here. But these towel rails are dual fuel, so we've reduced the heat curve from 1 to 0.4, turned the room stats all up to maximum, and the heat curve of 0.4 maintained 21 degrees throughout. So that will be much more efficient. Now, the hydraulic circuit here is also, I would say, over-engineered and not as efficient as it could be. Whether it's worth changing or not is another question at this stage, but I thought I'd explain it anyway. So here we have 4 pipes. We have 2 flows, 2 returns, 1 for each heat pump. So one of these heat pumps can do heating and hot water, the other can just do heating. The reason only one can do hot water is because it's only a 300 litre cylinder and we'll never need 2 heat pumps to heat this. But the heat pump that does hot water can also come on to boost the central heating if required. But I've done a heat loss calculation on this property. The result was approximately 12 kilowatt. So the second heat pump shouldn't be ever required to come in to boost the central heating, but on the system it can. I would say it's been oversized. However, the Vaillant controls are intelligent enough to hold off that second heat pump from coming on to boost the heating if only 1 heat pump is required and the flow temperature is reaching its target set point in a reasonable time. So how this works, we've got the flow from the heat pump that can do heating and hot water, comes in through here into this nice Belimo diverse valve, down here to hot water, or up here to central heating through this non-return valve, if it's ever required, if 2 heat pumps are required and 1 heat pump can't provide enough heat. The other heat pump, which is the primary heat pump for heating and only does heating, flow comes in here through this non-return valve and up here into this Vaillant plate heat exchanger system here. Now, we don't install this plate heat exchanger system because this is here so the installers can fill the primary circuit only with glycol, and we prefer to have antifreeze valves rather than glycol because glycol reduces efficiency, it's expensive, and we think it's far better just to simplify it and have the antifreeze valves outside. So because we've got this plate heat exchanger here, it's physical separation, we need to flow back there. From the return, we come down here, and the heating and hot water returns, they tee in, they link up here, and they go back to the heat pump through a filter, primary return filter here, back there, and just before it goes outside, it splits off to the other heat pump. Now, the secondary side of this here, so how we get from the heat exchanger to the underfloor heating and towel rails, is where it gets complicated and where we start to have some potential big efficiency losses here. So what we've got here, we've got another pump that just goes up into the plate heat exchanger and down across here to a 4-pipe buffer vessel here. Now, maybe the buffer vessel was required if the pipework's not in size large enough to be able to pump straight through off the built-in circulator pumps, or maybe they needed an additional volume in the system. But the way this works as a 4-pipe buffer is it provides hydraulic separation, but you also have quite a lot of mixing in here. So there's different ways of piping up buffer vessels if buffer vessels are required, so that you don't have as much efficiency loss, or you can balance the flows on either side of the circuits. There's lots of ways, which is a complicated subject of doing these buffers. Sometimes they're required, often they're not, but it's really what matters is how you pipe it up, how you commission it, how you balance the system, as to whether it's going to reduce efficiency or actually serve a very good purpose and do what it's supposed to do. So from this upside the buffer vessel here, we go into just down here. There's no separation here, it's all just one open chamber, and we flow back here and we go back to the other side of the plate heat exchanger. So we've got this pump here just pumping around the buffer vessel. On the secondary side, we come off here, and then because we've got hydraulic separation, we need another pump. So one pump we have on the top floor for the underfloor heating manifold up there, which I don't like having them all dotted around the pumps. I'd prefer to have, if they are required, I'd prefer to have additional pumps just here after the hydraulic separation. Anyway, we carry on down here and we tee off up here, and we have another pump just for our towel rail circuit. Or we come down here and we have another pump for this underfloating manifold, and we come along here and we have another pump just for that underfloating manifold there. And this, I would say, is far too many pumps, and the pipework can be sized so we require less pumps. But the reason this is done is because it looks like the installers have been provided with a one-size-fits-all schematic. They've not had a bespoke system design. And the first thing I'll do here is drain off the glycol, get rid of this system separation, then either pump straight through from the Vaillant built-in circulation pumps, or possibly if we did need to have the hydraulic separation, we would possibly just have one pump here to pump through the house, or we could just have the pumps for each manifold or all around here. I wouldn't have them dotted around the house as they are with more pumps upstairs as well. This is just not good for maintenance and not good for efficiency. So yes, so not as efficient as it could be. And that's how it works. Thank you for watching.